Now we look at the linear city model, which is a model for horizontal differentiation. Now what we'll do is we'll think of city as a straight line of length 1. And there are two firms, firm 1 and firm 2, which are located at either end of this line. Now both the firms, they simultaneously set prices at P1 and P2, and both the firms, they have constant marginal cost, and suppose marginal cost for both the firms is C. Now each firm obviously aims to maximize its profit. Now potential customers, they are evenly distributed along the line 1 at each point. Now each potential customer, it buys exactly same quantity, which is 1 unit in this case, and it can buy from either firm 1 or firm 2 depending on whichever price is lowest. Now customers, they are charged not just for the product but also for the transportation cost. So customer care about both price and about the distance they are from the firm. Now the transport cost in this game, it is given as T into distance square from any firm. Now we have to find Nash equilibrium in this game. Now for any customer which is situated at a distance x from origin, suppose this is origin, this is 1 unit, then this distance is x and this distance is 1 minus x. Now cost of this product from firm 1, it will be P1 plus Tx square, and cost of the product from firm 2, it will be P2 plus T into 1 minus x square. Now the customer, they'll always take the lowest price. Now what we'll do is we'll try and work out demand for both the firms, and for this what we'll do is we'll find this point A on this line where the cost of product from both the firms, it is equal. So at this x, price from both the firms, they must be same. Now we solve this, we get P1 plus Tx square, and it will be equal to P2 plus T plus Tx square minus 2xt. Now this Tx square will cancel. We'll get this x as P2 minus P1 plus T upon 2T. So this point A on the line is the point where this demand gets split. So all the customers from 0 to A, they'll order from firm P1, and all the customers beyond A, they'll order from this firm P2. Now if we write profit function for firm 1, then we can write pi1 as price is P1 and marginal cost is C. So it will be P1 minus C into its demand, and its demand is this value x. So it will be P1 minus C into x, and x is P2 minus P1 plus T upon 2T. So we can write this as P1 minus C into P2 minus P1 plus T upon 2T. Now we multiply this, we can write this as P1 P2 minus P1 square plus P1 T minus CP2 plus CP1 minus CT upon 2T. Now this firm 1, it would want to maximize its profit. So we'll find best response for firm 1. So we'll differentiate this pi with respect to its price P1. That will be P2 minus 2P1 plus T plus C upon 2T equals 0. So from here we can write value of P1 will be P2 plus T plus C whole divided by 2. So this is the best response of firm 1 for the price P2 set by this firm 2. Now we'll find profit function for firm 2. Now profit function for firm 2 will be pi 2, and there will be P2 minus C into its demand, which is 1 minus x. Now this is P2 minus C, and 1 minus x will be P1 plus T minus P2 upon 2T. So as we can see, there is symmetry in this game. Here it is P1 minus C, P2 minus P1 plus T, and here it is P2 minus C, P1 minus P2 plus T. So using symmetry, what we'll do is we'll say Nash equilibrium of this game will be when P1 equals P2 and it is equal to P. So from here we can write 2P equals P plus T plus C, or value of P is T plus C. So unique Nash equilibrium of this game is when both the firms they charge the same price and this price is equal to T plus C. And at this price, since P1 and P2 they're equal, value of X is 1 by 2. So they'll split the demand equally between them. So in this case, products are essentially same, but they are being differentiated due to this transportation cost, which is a case of horizontal differentiation.